All right, with the coterminal, just quick review of what coterminal is. If I have an angle here, so this is the terminal side of an angle. I could have one angle here. I could also have it go around this way. I could also have it go like this. So what coterminal means is you have the same terminal side for multiple angles. Because those are not the same angle, but they all have the same terminal side. They all end in the same place. What we do to get from one angle to its coterminal is we go around the circle, right? I can get from this angle to the green one by going around the circle once. I can get back to this by going around the circle again. So mathematically, how do I find coterminals? How do I go around a circle mathematically? Yeah. I can add or subtract 360. Or, if I'm working in radians, what am I going to add or subtract? 2 pi. Now, I can add or subtract 360 or 2 pi as many times as I want to, correct? So what we do is we put an n in front of that. And we say n is a natural number. Well, actually, we want it to be a whole number because we want to have the option of not adding it at all. There's lots of different ways of defining it. You could say plus or minus, or we could just say plus 2 pi n and make n an integer. Then you don't have to have the minus. Okay, so this is how we do it. So anytime we want to do this, the way your book's going to have you do it, the way you're going to be asked to do it on the test is you're going to be given an angle and you're going to be asked to find one positive and one negative coterminal angle. So, however you're given the angle is how you're expected to give your answer. So if you're given an angle in degrees, you want to give your answer in degrees. So, to find a positive one, I could just take 40 plus 360. So there's a positive coterminal angle. If I want to find a negative coterminal angle, there's a negative. Now, before we move on to radians, which is a new topic in itself, does this make sense, how we find coterminals? We just go around the circle again. If we want to find a negative one, we go around the circle backwards. All right, so let's do this for radians. So I would add 2 pi. Now, since I'm dealing with fractions, I need that to be in fifths, so 2 pi would be the same thing as 10 fifths. So I get 11 fifths. Now, after you get used to doing this, you get quicker at coming up with your fractions. So you'll be able to spout off quickly, hopefully by the end of the semester, that this would just be 9 fifths without having to go through all this work. Or sorry, negative 9 fifths. Because this is just 1. I'm going 1 less than 2, so that's just going to be 9 fifths. You okay with that? So let's do a hard one. Why? Alright, so find a positive and a negative one for 7 halves. Okay, there's some possible solutions if you get that far. Those are possible because remember, there's infinitely many answers. Now, if you stuck with the way we were doing it, if you take 7 pi over 2 plus 2 pi, you would get 11 pi over 2. If you took 7 pi over 2 minus 2 pi, you get 3 pi over 2. The problem I see on the test is people stop there. They're like, great, I subtracted it. Problem is, that's not an answer. That is an answer. That's an answer for a positive coterminal. But that's not a negative coterminal yet, because it's not a negative number. So you have to do it again. You can keep adding or subtracting as many times as you need to. But you have to keep doing it until you get to a negative number. So what I have to do is I have to take that and subtract it again. So the first negative I get to is negative pi over 2. Yep. The what? Because that was the one you were given. You're looking for a coterminal to it, so you have to find another one. Now you could, if you know that that one is big enough that you're going to have to subtract more than once, you could give me the 3 pi over 2 as a positive coterminal.
And so you can, if you want to fit
Yeah. Yeah, I mean, if you want to go overboard and you want to add 2 pi 5 times just to for the hell of it and give me a huge ass number, I don't care. It wastes your time, not mine. Yeah, any positive coterminal. I mean, yeah, I can subtract 2 pi 5 more times and find a really negative coterminal. All right, you guys okay with coterminals? All right. So let's talk about formulas and then we'll be done. So let me go over some of the formulas that you guys will need for the story problems. None of these formulas, I'm not asking you to memorize any of these. Okay? These are formulas just to get you used to using radians and degrees. That's the only purpose of these. If you need any of these on a quiz or a test, I would give them to you. All right, first one is arc length. So this is, it doesn't even have to be on a circle, but if you have a curve, this is the actual length of the curve. So length of the curve is S. Use theta to represent that, and R is the radius. So arc length is equal to radius times theta. So again, S is arc length. R is radius. Theta is your angle in radians. The formula gets a lot more complicated if you put it in degrees. So what they're wanting you to do is, if you're given an angle in degrees, they're wanting you to convert it to radians. Okay, what this is if you have a particle traveling along an arc, if it was to leave its arc path and actually just travel off in that direction, what would its speed be in that direction? That's linear speed. So like if it's tied to a rope and suddenly the rope was cut and it just flew off in that direction, what would its speed be? So linear speed is v. S again is arc length. And t is time. Okay, angular speed is the actual speed along the curved path. And again, this angle is in radians. Okay, one last one. If you have any questions about these formulas as I'm going, speak up, say something. That does not look good. Oh well. Hopefully you can read it. Theta is the angle in the middle. Again, this is radius. Theta is again in radians. A is the area of the sector. Alright, so those are the formulas that they're going to ask you guys to use for the story problems. A lot of it is just to get you to do more work with changing degrees to radians and using radians more in actual problems. Okay. Okay, I do not know why that. Okay, this is ridiculous. I'm writing way more than I need to write. 17 through 19 odd is actually 17 and 19. 39 through 41 odd is 39 and 41. I might as well put 107 odd. 97 through 101 odd is there's actually a number in between those two. I know.